Hey everyone, welcome to Control-Alt-Delete. We'll be solving LeetCode problems to learn a programming language. This series is for learning Rust. Today we are tackling a classic problem from line 75 list. Finding the longest substring without repeating characters. This is the fundamental concept in string manipulation. Let's break down this problem. Given a string and the goal is to find the longest sequence of characters where no character repeats. We are going to use a sliding window technique. Imagine a window that moves across a string, expanding or shrinking as needed. Let's walk through an example. We'll start by adding the first character A to our sliding window, then we add B and C follows. Now when we come across another A, we realize we have a duplicate. For a valid window, we cannot have repeating characters. Therefore, we need to shrink our window. We remove the original A. We then add the new A, making our window BCA. By consistently checking for uniqueness, expanding the window when possible and shrinking it when the duplicates are found, will ultimately determine the longest non-repeating substring. We keep progressing, keeping track of maximum length we have seen. Let's dive into the coding section. First up, we gotta figure out how to go through each character in a string. In Rust, we do this using the chars method. It gives us a way to look at one character at a time. We can then use a for loop to do stuff with each of these characters. Now, strings themselves are a little tricky to change. It's convenient to use a vector. We turn our string into a vector by using the chars method, then the collect method into a vec. We make this vec mutable, so we can change the individual characters, say the one at index 0. Next thing we are talking about is a hash set. This is useful to know if you have seen a character before, especially when checking for duplicates within a window. Rust provides this hash set and we are going to use it to see where characters are unique. We can loop over the characters of our vec and then use insert method to add them into the set. Now we need to check if a character is already in the set. We use contains for that. Remember to use a borrowed reference with the ampersand symbol. If the character is in there, it means we have seen it before in the current window. So we remove it using remove method, also with a borrowed reference. Now let's go over the whole code. We are using a right pointer to iterate through the string. To see if our window of characters is good, we check if the character at R is in the set. If it is, we have got a duplicate. So we got to get rid of this character at the left pointer to shrink the window a bit. If it's not in there, it means the window is valid. We work out the length of a window, update the max length if needed, and move the right pointer along to expand the window. Let's run this code and see the output. Let's look at another approach. Using vector of character to store characters can be inefficient because it allocates 4 bytes for each character. A more memory-friendly approach is to work with bytes directly. We can convert a string to a bytes array using asBytes method. This allows for faster iteration since bytes are stored contiguously. For example, if we convert a string to bytes and print the first byte, we'll see its ASCII value. Now let's explore another technique also using bytes. First, we'll turn our string into a byte array instead of using a hash set to keep track of characters, which can be inefficient for long strings. We'll use a fixed size boolean array called ASCII set. It has 128 elements corresponding to the range of ASCII values. We start with all the elements set to false. As we iterate through bytes using a right pointer, we check if ASCII set is true at the index corresponding to current byte's ASCII value. If it is, it means we have seen this character already. We then set ASCII set at the left pointer to false and advance the left pointer. If it's false, we mark it as true in the ASCII set and move the right pointer. We ran into an issue where we tried to use the byte value directly as an index into ASCII set. which isn't allowed. We need to convert the U8 byte value to a U size to use it as an index in our array. Thanks for watching. I hope you enjoyed the video. If you did, don't forget to hit that like button, subscribe and ring the bell so you never miss out on future content. Feel free to leave a comment below with your thoughts or any questions you might have. See you in the next one.